who all are joining, please leave a message. Parita, very good afternoon, beta. Welcome to the session. Okay, so am I loud and clear to everyone? Sanya, hello. Very good afternoon. Pooja, hello. Mandi, good afternoon. Jai Hind, Vande Mataram. Yash, Rishikesh, Shilpi, Vaibhav, Ishan, Devesh, Anand, Vaibhav. Thank you. चलिए शुरू करते हैं आज का लेक्चर. So that is in the previous session we have discussed about atmosphere, the composition of atmosphere and the structure of atmosphere. Thank you, Parita. In this today's session, we'll be after that we will discuss winds, the type of winds like your primary winds, entry winds, and the local winds. In this session, today's session, we'll be discussing about the pressure winds. Then we'll be discussing about the precipitation, types of precipitation, cyclones, anticyclones, tropical temperate cyclones. Aishwarya, very good afternoon, beta. After that, we'll be discussing about your types of clouds, and after that, we'll be discussing the questions. Okay. Mandeep. Okay. So the course as well as the PDFs that are more than sufficient, plus previous year questions. Mandeep. Priyanka, Bharti, Gorak, hello, very good afternoon. सुखमनजोत, सबका बहुत स्वागत है. चलिए शुरू करते हैं आज का सेशन. गौरी, अदनान, सुखमनजोत, ठीक है. Now, okay, current affairs कैसे प्रैक्टिस करूं? गोराक, वैसे we are discussing the current affairs in the sessions, and we are discussing the questions as well. PDF means notes or your class PDF, both, Mandi, both should be combined together. Okay, both should be supplemented, both should be like go hand in hand. चलिए शुरू. तो now do you remember the primary winds? हाँ जी, the trade winds, westerlies and the polar easterlies. ठीक है जी. Okay. No, you don't have to like sorry, honey. Okay, Shilpi, हाँ जी, याद है ये सारी चीजें. Have you do you remember this trade winds? Trade winds में we have discussed like northeast trade wind and southeast trade winds, then westerlies, then polar easterlies, then ITCZ. Now, based on the similar thing only, what we have observed that in this low pressure belt where your air was rising, this is what we call the equatorial low pressure belt. This is what we call the equatorial low pressure belt. This belt, and this belt is what we call the subtropical high pressure belt, and this is okay. So the air was subsiding over here. So you have the subtropical high pressure belt. Now, why we call it as a pressure belt? Because you find the similar pressure conditions in this particular region. Okay. Similarly, because of warm air and the cold air mass, both are joining and your warm air mass is rising. So you have the low pressure over here. That is what we call the subpolar low pressure. So this is my first class. Narayan. Oh, sorry, Mandeep. Mandeep. It would be very difficult to like explain the things again. Okay. I think it is my humble request to please go through the previous lectures, because in the also please explain again. Anjali, if this is your first session, so okay, my first class also. Korak is saying Aishwarya is saying my first class also. Mandeep is saying first class also. Then how can I like start from the fresh? Okay, it would be very difficult for me to start my also. अच्छा, सबका first class आज. तो कोई पुराने sessions वाले भी हैं. अच्छा. This is like all the students are like the first. They are attending the first lecture. अच्छा, यशवंत कह रहे हैं कि I'm from the first class fly up. हाँ, ये मेरे को पता है, पुराने भी हैं सर. Okay, not fresh yet, started 3-4 days back. Okay, Sanya, no sir, you should continue your class. I'm regular. Okay, so चलिए, Parita is regular, Shilpi is regular. मेरा भी first है सर. ठीक है. So I request all those who are new to the class, so please guys, please refresh. और 21 से enrollment हुआ था. Fair enough, Gorak. But I would suggest you to please go through your previous lecture, so that is your recorded sessions, because otherwise you will not be able to like streamline yourself. ठीक है? हाँ. ठीक है. वैष्णवी, I'll पहले इस चीज को clarify किया जाए. So let's clarify those who are new. So it's my humble request, because if I'll start from fresh, I can start from the fresh, but in that case I will not be able to complete my lecture in the stipulated time. ठीक है. So it is my humble request to all those who are like joining for today. So please go and watch the previous lectures, at least the climatology lectures. At least go through the lectures which we have discussed in the climatology part. And before that, what we are discussing in geomorphology, at the same time, start reading those lectures, revising those lectures. If you find any sort of problem, we'll discuss in the class. Okay, topics क्या हुआ है, जस्ट बोल दीजिए सर. बेटा क्या हुआ है, बहुत कुछ हो गया है, पूरा जियोमॉर्फोलॉजी कंप्लीट हो गया है. इन दैट वी हैव डिस्कस कॉन्टिनेंटल ड्रिफ्ट थ्योरी, प्लेट टेक्टोनिक्स थ्योरी, लैंडफॉर्म्स, ठीक है. Then we discussed about the composition, the structure of the atmosphere. Then we discussed about the your winds, ठीक है. Okay. Next, now let's talk about the pressure belts. So pressure belts are those areas in which you find the similar pressure conditions, like your equatorial low pressure belt. That is what we call the doldrums. So that in this belt your air was rising. The air was rising, so that led to your low pressure. Here your air was subsiding. That we have discussed in very detailed manner in the previous session. Similarly, in the polar high pressure belt, since the pressure you have the subsiding pressure because of the cold and dense air that will sink, that will subside. So you will have the polar high pressure belt. Whenever you have this westerlies and polar easterlies coming towards each other, okay, Korla deep was a joke if you get okay बेटा जोक का भी मैं टाइम दूंगा. मैं बीच में 2-3 मिनट जल्दी, बीच में 10-15 मिनट बाद खुद ही जोक मार दूंगा. तो सबके बिहाफ में मैं किसी ना किसी को जोक मार ही देता हूँ. तो आप जोक ना मारे कोई भी, ठीक है. और उसकी जो है व्हाट इज फ्यूरियस 50s, ठीक है. ठीक है मनदीप, मैं फ्यूरियस 50s पे भी आऊंगा, ठीक है. प्लीज होल्ड ऑन. ओके मनदीप, ठीक है जी. पहले एक बार टॉपिक को शुरू करते हैं. ओके सर, टेल मी 2022 सीरीज. 2022 सीरीज का बेटा मैं इसमें एनीथिंग स्पेसिफिक यू नो नूरेन, मोहम्मद नूरेन. सो बेटा रिक्वेस्ट ये है कि आज अभी हम टॉपिक पे डिस्कशन करेंगे. स्ट्रेटजी पार्ट CDS 2 में क्या क्या है, इसके लिए अलग से सेशंस है. अगर हम दोनों चीजों को मिक्स करेंगे तो हम अपने टॉपिक से वी विल बी डाइवर्टिंग फ्रॉम आवर टॉपिक. No, Lokesh, I will not be talking in Hindi. I will not be explaining the things in Hindi because this is an English batch. If you want to attend, you can attend the bilingual batch. ठीक है जी. No, these are more than sufficient. We are going in a very detailed manner, Anjali. ठीक है, let's start. Should we start in this lecture now? Okay. So you have the high pressure belt. So you have the air is rising over here. So again that is subsiding, and here is also it is subsiding. So let's talk about now. You have the 7 pressure belts. You have the 7 pressure belts. One is your equatorial low pressure belt. 2 is your subtropical high pressure belts. 2 subpolar low pressure belts and 2 polar high pressure belts. So let's talk about first of all equatorial low pressure belt. So it lies between your 10 degree north and south of latitude. So just see. So 10 degree north and south of latitude is your equatorial low pressure belt. Now what it is this? It is a zone of convergence of trade winds. Now I hope you remember the trade winds. So from subtropical high pressure belt, so you have the northeast trade wind and the southeast trade wind converging towards each other. So this is your northeast trade winds and this is your southeast trade winds. Both are converging towards each other. This is also known as doldrums or the belt of calm. Okay. Now what happens, why it is called belt of calm or why it is called doldrums? Now it is an interesting story that since the air is rising and there is not much of a horizontal wind. There is not much of a horizontal wind. Now what is this horizontal movement of air? That is what we have discussed in the previous session. That is wind. Horizontal movement of air is your wind. Okay. So since you don't much of the air is rising, you don't have the horizontal motion of air. So you will find a very calm condition. You feel like you are stuck into this region. You will not be able to move actually. So that is why it is called belt of calm. So moreover, since you have a lot of heating and lot of insolation, you have a lot of incoming solar radiation, you have a lot of convection. So that will lead to your cloud formation. That will lead to your आवाज आ रही है मेरी? Aishwarya is saying can't hear anything, sir. Aishwarya, there is a option called audio fix issue. ठीक है, so please click on that. And okay, thank you everyone. So since you have a lot of insolation in this belt, because of that what will happen? You have the convection, and again that same example of what we have discussed in the previous session. If you remember that example of rising, it is getting saturated because the temperature is decreasing, and that is leading to the cloud formation. So that is also known as convectional rainfall. Convectional rainfall. I'm not able to see and hear you, sir. Aishwarya, please refresh the session or rejoin the session. Okay, ji? Aishwarya. Okay. Now, unpredictable weather patterns with very stagnant calms. So I told you that because. Okay. Please tell someone, Aishwarya, that she can rejoin or refresh. Okay. So unpredictable weather patterns. Okay, unpredictable weather patterns with stagnant calms and intense thunderstorms, absence of surface winds. Okay, now, because of this intense convection, now what will happen? That you have a rainfall on a very daily basis, approximately on a daily basis. That during the daytime there is so much of a convection. Stagnant means you don't find a horizontal movement. Simply, you don't find horizontal movement of air. Since you have a lot of convection, so because of that, you have a lot of cloud formation. That is your cumulonimbus cloud that we will discuss eventually in this lecture only. Because of this, now you have a rainfall from every day approximately from 2 to 4 p.m. Okay. Now, it does not mean that exactly 2 o'clock rainfall will start at 4 p.m. पे खत्म हो जाएगी. Okay. So this will not happen. Or if there will be a rainfall at 1:45 p.m. or 4:50 p.m. You say, sir, मेरे को गलत पढ़ा है. Okay. So that is an indicator. Okay. So this is an idea, just an idea that you have the rainfall approximately about 2 to 4 p.m. Okay. So that is you have unpredictable weather patterns with stagnant calms and intense thunderstorms. Why intense thunderstorms? Because you have a lot of convection. Because of that, you have a lot of rainfall. 4 o'clock rainfall. 4 o'clock rain. Korak, that simply means that you have a lot of convection. Because of lot of heating, low pressure is being generated, the air will start rising. That will lead to your cloud formation because the air is getting saturated. Relative humidity is reaching up to 100%. ठीक है, relative humidity. Yes, वही बोल रहा. Korak, please थोड़ा explain कर लो बेटा. Please elaborate your statement. So absence of surface winds. Now this is you don't have the surface winds. Where this is found, sir, equatorial low pressure belt. Better 10 degree north and south of latitudes. Okay. Second point. So zone of convergence with trade winds between subtropical high pressure belt. Okay, see in this diagram. So what is this? So you have this. So you have this northeast and southeast trade winds. Okay. So in India, some states have daily rainfall. They also have convections. Yes, not all the states have daily convection, James. If you're talking about the Mozambique and the Meghalaya's, that is a different reason. Okay. We'll talk about it in the tomorrow session. That is your Indian monsoon climate. Okay. So Vivek is saying zoom करके दिखाओ. So let's forget about the zoom. So this is the zone of convergence that we have discussed in the previous session about ITCZ. Do you remember that ITCZ? That is intertropical. So what is intertropical means? Between two tropics. That is your convergence. That is both the northeast and southeast trade winds are converging. That is zone. That is ITCZ, intertropical convergence zone. So that is the zone where your southeast and northeast trade winds are converging. Next is your subtropical high pressure belt or the horse latitudes. Okay. Vinay, I have not yet discussed subpolar low pressure belt, though we have discussed in the previous session also. Okay. So it's my humble request to all those who have read earlier the topic about this. This is not a platform to ask the random doubts or to show your knowledge. You will get the time. Okay. You will get the time to ask your doubts. Let's not disturb the flow of the class. We have to take along every student. Okay. Have the OLQs, have the necessary OLQs. Okay. आपकी तैयारी यहीं से शुरू हो रही है ऑफिसर बनने की. That is officer like qualities. Okay. You have to take those students along also who are reading this topic for the very first time. Okay. So at least have that OLQs. Team spirit. ठीक है जी. चलिए. Okay. चलिए. Subtropical high pressure belt or the horse latitudes. So subtropical highs extend from near tropics around 30 to 35 degree north and south. So that is your subtropical high pressure belt. So what is happening? So air moving away from the equatorial low pressure belt. I was telling you that the air which is moving from the equatorial low pressure belt in the upper troposphere becomes dry and cold. So as and when your air is rising, what is happening? Because in the troposphere, we have discussed in the previous session that your temperature is decreasing in the troposphere. Okay. In stratosphere, then it starts increasing. Now, since the temperature is decreasing, so that air will start becoming cold, okay, becoming heavy. So that will eventually be subsiding over here. So that is why you have the high pressure because of the subsidence of the air. Okay. So this dry and the cold wind subsides at approximately 30 to 35 degree north and south. Okay. So 30 to 35 degree north and south. You find this subtropical. Now, why it is called subtropical? Because it is beyond the tropics. Okay, it is near the tropics. So, what is tropics? So that is your Tropic of Cancer and Tropic of Capricorn that we have discussed. That is 23.5 degree north and south. So, you find this as a 30 degree, 35 degree north and south. Okay, why it is called horse latitudes? Now, what happened in the early days? The sailing vessels, they used to carry the cargo of horses. Now, again, the same thing. the air is subsiding, so you don't find much of a horizontal movement. You don't find a horizontal movement of air. So they used to throw the horses just to like ensure that they like they find it hard to sail under the very calm conditions. You find the very calm conditions. So they used to throw the horses into the sea. So hence the above name, that is your horse latitudes. Okay. So somebody was asking me about subpolar low pressure belt. Okay. Simply means Shilpi, that since you have the subsidence of the, I'll explain again Shilpi. So since your air is subsiding, you don't have much of a horizontal movement. So you find it hard to difficult. So what you do, you simply throw the horses so that you can be light, so that at least your ship can move. Okay, so that is the name. How this is the name come your subprogram. Your horse latitudes, Shilpi. Okay, last line. Okay, I'm going. Next is your subpolar low pressure belt. Now this subpolar low pressure belt lies between your 50 to 55 degree north and south. So, though it varies, like it shifts also, that we will discuss in the coming slides. Now subpolar low pressure belt. Now what happens? So the warm air mass coming from the subtropical high pressure belt and the cold air mass coming from the polar high pressure belt. So the air is start rising over here. So that is how you find the subpolar low pressure belt that we have discussed in the previous session also. Okay. Now it is very interesting to know this thing, what is dynamically produced. So it is being said that your subtropical high pressure belt and this subpolar low pressure belt both are dynamically produced, basically produced due to effect of the Coriolis force. Now, for example, now do you know that Earth is rotating? Yes, it varies. Mandeep, I'll come to that also. In some book, it is written 60 to 65 degree north and south also. It varies, it shifts. Okay, Mandeep, it is not fixed that it is between 60 to 65 degree north and south. The Earth is rotating on its own axis. Okay. Now, what happens because of that? You have the Coriolis force. Now we know that what is Coriolis force. That is your the wind tends to deflect towards the right in the northern hemisphere. The wind tends to deflect towards the left in the southern hemisphere. Fair enough. Now, what happens because of this? That your subpolar low pressure belt and subtropical high pressure belt is also being formed. It is being said that ideally what should happen? So the air which is rising over here over the equatorial low pressure belt, it should directly go towards your polar high pressure belt and the air. So you have a high pressure over here, so you have a low pressure over here. So the air should move like this, high pressure to low pressure. But why it is not coming directly? Because in between, because of the rotation of the Earth, what is happening? You are having two more belts which is being formed due to the rotation of the Earth. Because of the Coriolis force, because of the centrifugal force, you are finding two more belts. So that is why, Pooja, now what is centrifugal, what is centripetal? That you must have read in your physics classes. Okay, so I'll explain again. So what is this dynamically produced belt? That means that is due to the rotation of Earth. Now it does not mean that these two belts are formed, do not have any temperature role to play. But whereas these two belts, equatorial low pressure belt and polar high pressure belt, they are thermally induced belt. Now what is this thermally induced? Thermal means temperature. Now what happened? We said that you have a lot of temperature over here. You have a lot of insolation over here. Here you have a a lot of subsidence over here. In the polar high pressure belt, you have a lot of subsidence over here, moving or tending to move away from center. So answer to okay. So Coriolis force and centrifugal force. So the temperate cyclones happen due to the mixing of the two air masses that we will discuss in a very detailed manner in this session. Temperate cyclones and tropical cyclones. So that was your subpolar low pressure belt. Last is your polar high pressure belt. You can see here. So the polar highs are very small in area comparatively and extends around poles. Now poles make you have a very low temperature. Now since you have a low temperature, the space between the molecules will be very less. So what will happen? The density will be very high. So that is mass per unit volume. That will be very high because you will have more mass per unit volume. So the air will subside. So you will have the polar high pressure belt. So they lie around the poles between 80 to 90 degrees south, north and south latitudes. Is mostly also due to Prashant. That is not the today's topic that we will discuss tomorrow. Okay. Subside means this subsidence. Shilpi. One is rising of air, one is subsidence of air. Okay. Got it? यहाँ तक समझ आया? Polar high pressure belt. Okay. One of you were asking me about furious 50s, roaring 40s, screaming 60s. Now what happens? What we have discussed about the winds, the type of winds, especially your primary winds. In the, that we have discussed about your trade winds, your westerlies, and your easterlies. Now, what happened in your southern hemisphere? If you clearly, closely observe the southern hemisphere, you will see that south of 40 degree in the southern hemisphere, or you can say 40 degrees south, you hardly find any landmass. You can see 30 degrees south. So this is your 40 degrees south. You hardly find any kind of a landmass. Now, what happens because of that? Okay, Aishwarya. So, fair enough, Aishwarya, you can watch the recorded session. Okay, so trade winds, westerlies and easterlies. So what happens in the southern hemisphere? This westerlies become very aggressive. Now you don't have any barrier, hawa ko. So that wind does not have any kind of a barrier. So that becomes very aggressive. Now what happens in the previous times? No boundaries, yes, Shilpi. Now what happens in the previous time?
रोटी खा लेना पूजा पूजा अरे बंद हो क्या सुन रही हाँ
Okay, am I audible now? Am I audible now? Okay, thank you. Okay, thank you so much. So there must be any sort of error, technical error. So I'll repeat once again. So what happens in the southern hemisphere? What happens in the southern hemisphere? A very interesting thing happens that whenever the sailors used to sail in the southern hemisphere, since you don't have any sort of barrier, since you do not have any sort of barrier, these westerlies and polar easterlies become very, very aggressive in nature, and they find it very difficult. The sailors find it very difficult to sail through this things. So they have named it this roaring 40s, furious 50s, screaming 60s. Now, why don't you find in the northern hemisphere? Because you find a lot of land masses. Okay? So you will not find that your westerlies and polar easterlies becoming so furious, okay, or so noisy or so aggressive in nature. Okay? Sailing is difficult in these areas. Yes, Mati, that is the reason. That is the roaring 40s, furious 50s, and screaming 60s. Okay, चलें आगे. Okay, now this is very important. The shifting of pressure belts. Now what will happen because of this shifting of pressure belt, that we will see tomorrow also. Now, first of all, what is shifting of pressure belts? Now, when I'm saying that my insolation is, I'm getting the maximum insolation in the equator region, but we know that Earth is tilted. Okay, Earth is tilted on its axis, and it is revolving around the sun also. When it is revolving around the sun, it is somewhat like this. It is revolving around the sun. So we have discussed that also, that 22nd of June, that is your summer solstice, that you have the direct sun rays on the Tropic of Cancer, that is 23.5 degree north. Whereas on the 22nd of December, 21st or 22nd of December, this doesn't matter much. So that is your winter solstice. Okay, that is your winter solstice. So you have the sun rays directly over your Tropic of Capricorn. Okay, Tropic of Capricorn. So what will happen because of that? It is not fixed also. Correct. 21st or 22nd June or 22nd December. Okay, 21st June ko hi hoga Tropic of Cancer. Basically, what is summer solstice? That basically means that your sun rays are directly overhead the Tropic of Cancer. Okay, so that might happen on 22nd June also. Okay, correct. Answer to your question. So now what happens because of that? Your pressure belt shifts also. What will happen in the month of December, January? What will happen? Your pressure belts will move towards the south, because maximum insolation you are getting at which place? Tropic of Capricorn, that is 23.5 degrees south. And in the month of June and July, what will happen? So you will get the maximum insolation at your Tropic of Cancer, that is 23.5 degree north. So that is how this pressure belt shifts also. So shifts towards the north in July, shift towards the south in January. Now this ITCZ is also known as the thermal equator. That is why it is also known as thermal equator. If sun rays directly fall on the area, will it become the longer day? Not exactly that is the reason, but but simply we call it like the sun rays are directly overhead between the Tropic of Cancer and Tropic of Capricorn. So that moves in this only. Okay. So what will happen in this? So Vaishnavi, what will happen? So you have the, like, your ITCZ will be moving towards like this part, okay, in the month of June, July, and ITCZ will be moving towards the south in the month of your December and January. Okay. So June, July में आपका what will happen? So your ITZ will move towards the north, and in the December, January it will move towards the south. Now accordingly, other pressure belts will also move. According to that. Okay. So that is your shifting of pressure belts. So belt of highest temperature also shifts along the belt. Now please ask me. This is all about your pressure belts. Any doubt till this point? You can ask a doubt. So this is all about pressure belts. So what we have discussed, we have 7 pressure belts. In that we have discussed about equatorial low pressure belt, 1 equatorial low pressure belt, 2 subtropical high pressure belt, 2 subpolar low pressure belt, and 2 polar high pressure belt. Shilpi, you're asking about this point. You're asking about this point. Now, what I'm saying, what is equator? So equator is that latitude. Can northern belt completely shift to south? Northern belt, okay, MOE. Subtropical pressure belt. Okay, I'll come to that. What is equator? That is 0 degree. So that is that latitude that divides the earth into 2 equal parts. That is why we call it equator. Equate से आया है आपका term equator. So that is the dividing that latitude that is dividing the earth into 2 equal parts. Okay. Now what we are saying that that your this pressure belt. Now since your Earth is tilted on its axis. Now, it is not that you find the maximum insolation at the equator. Because since Earth is tilted, so at one point of time, this area will get the maximum heat, and at other point, this area will get the maximum heat. Okay? So it will rotate like this, revolve around like this. At one point of time, it will be like getting this. This point will be getting the maximum heat, and other point, this point will be getting the maximum heat. Okay? Now, because of that, your pressure belt. Since your pressure, now what is the first thing we have talked about, the low pressure and the high pressure? That is the temperature. I told you that since you have a low temperature, so the air is rising, so that becomes your low pressure area. I told you that you have a very low temperature, so you have the high pressure area, because the air is subsiding. Now, since your temperature, which area is getting the maximum temperature, if that is shifting, accordingly your pressure belt will also shift. If your that areas where you get the maximum of temperature is shifting, so accordingly your pressure belt will also shift. हाँ जी, शिल्पी ये समझ आया point? Have you got this point? Okay. Can northern belt completely shift to? No, it is not that northern belt. It is the ITCZ. These are the pressure belts which are shifting. MOE. These are the pressure belts which are shifting. That 7 pressure belts which are shifting according to the movement of the sun. Ideally, it is not the movement of the sun. It is the revolution of the earth. Because of that, your pressure belt is shifting. MOE and Shilpi and other guys who have got this point. ITCZ की full form क्या है? ITCZ की full form I have told in the previous session also. It is also intertropical convergence zone. ठीक है जी? How is there more insolation at the equator? Because that area is getting more of a sunlight, direct sunlight. Okay, Chandranshu, we'll see from this as an example. Okay, let's try to understand from this example. What happens in the winters? You try to sit in the sunlight. What you say, okay, जो sunlight है, so that is coming like this way. Okay, like this way. Okay. What happens in the summers? You say that sun rays are getting like this way. So you are getting sun rays directly overhead. But during the winters, you say that your sun rays you are getting the sun rays at a tilted in a certain direction or in a tilted manner. So what will happen? Suppose you take any torch. Okay, take a torch. So put the torch directly over a piece of paper or in this tilted manner. So what will happen? In this, when it is directly overhead, it will get more energy per unit area. Isn't it? Yes or no? And if it is tilted, it will get less energy per unit area. हाँ जी, ये चीज समझ आई. Basic simple experiment that we used to do in your classes, 7th, 8th class. ठीक है जी. Okay, Chandranshu. So that is the reason that equator में you find that more of a energy, and at the poles. Now what happens at the poles? You are getting this tilted sunlight. ठीक है जी. चलो. Now let's go ahead. That is next topic is your precipitation. The presence of warm, moist, and unstable air and a sufficient number of hygroscopic nuclei. Now warm, moist, and unstable air. Now what this means? That your air is rising. Do we have discussed that cold water bottle example in the class? And boy saying no. बहुत बढ़िया बेटा. ठीक है. I remember that we have discussed in the class. That is why temperature of the pool is less due to tilted. Yes, Prashant. That is one of the major reasons. Not in this batch. And boy, बेटा we have discussed in the on Friday. ठीक है. चलो एक बार. Yes. ठीक है. I'll repeat. Don't worry. I'll repeat. Just take that example of, just for your understanding. Just take a chilled water bottle and keep it in the open for half an hour. What will you find after half an hour? Water droplets you will find over here. You will find the water droplets over here. Now what is the reason of the water droplets? Now the warm air which comes in contact with it. Okay. So it becomes cold. So relative humidity will increase. Now what is humidity? What is absolute humidity? So that is amount of water vapor per unit volume of air. So in unit volume of air, how much water vapor is there? So as the temperature will come down, so that will not be able to hold much of a water because the space between the molecules will decrease. When the space between the molecule will decrease, it will not be able to hold on the water. If that will not be able to hold on the water, or I can simply say that relative humidity, which was earlier say 80% or 90%, that will achieve 100%. Or simply, in simple words, we say that saturation happens. Or in very simple terms, we call it as a condensation. That your water vapor will condense. Water vapor present in the air will condense into water droplets. Okay. So exactly this is what happens when your warm air is rising. When the warm air is rising, the temperature is decreasing. What will happen? So that water vapor will start converting into water droplets. Now, where this water droplets started forming, so that is your, do you remember that what we have discussed in the atmosphere? That is your blanket of gases and solid and liquid particles. That is what we call have aerosols. Okay, aerosols, solid and liquid particles. Now this around these solid and liquid particles, your water vapor will start accumulating, and as in when it is going upwards, it is cooling down, and that water vapor will start converting into water droplets. When this huge water droplets is not able to hold on itself, it will start falling down. That is what we call the precipitation. Rainfall, snowfall, various names. So what is falling down is what we call the precipitation. ये किस किसको समझ आया? Who all have got this? The whole thing, the cloud formation part. आइस वाला बारिश कैसे? ठीक है, आइस वाला बारिश कैसे होगा वो भी बताऊंगा. Video is not coming upright sometimes. Okay, please check your connection. Vinay, I think from my side it is fine. Okay, so what it has written now, let's see. The presence of warm, moist, and unstable air and a sufficient number of hygroscopic nuclei are the prerequisite conditions for rainfall. ठीक है जी. So the warm, moist air, prerequisite मतलब पहले earlier conditions, the necessary conditions. ठीक है. Okay, so the warm, moist air after being uplifted upwards becomes saturated and clouds are formed after condensation of water vapor around hygroscopic. That whatever I have explained you is being written here. ठीक है. For your future purposes. ठीक है. Now take types of rainfall. Types of rainfall. First of all, what is precipitation? What is precipitation? Now precipitation is a broader term. What is the difference between precipitation and rainfall? Difference between precipitation and rainfall. Anybody having any idea? Difference between precipitation and rainfall? No. जो भी मेरे साथ लाइव है, rainfall falling of liquid only. Basically, precipitation consists of many things like your rainfall, snowfall, hailstorms, sleet, drizzling. So that is like a much broader term. So precipitation is a much broader term. Rainfall is an example of precipitation. Good, Rishikesh. Precipitation includes rain, snow, etc. Good, Yashwant. ठीक है. Yes, I'm going. Please give time to write. After the class also you can write Shilpi because I have to discuss a lot of things. I know now this is a okay. As you explained the precipitation things which fall so many things consist of it and rainfall is a part of it. Yes. Okay, no in the chat box. अच्छा, please give time to write in chat box. अच्छा. ठीक है. चलो. So types of rainfall on the basis of region, we divide the rainfall into 3 types. So first of all is your convectional rainfall. ठीक है. Exactly the same thing what we have discussed in the equatorial low pressure belt. So the air, this particular surface is very warm. The air is rising. So that is leading to your formation of clouds. So that is falling down. So simply because of the convection, simply because of the heated surface, the air is rising. That is cooling down, and that is leading to the rainfall. So that is your convectional rainfall. Where it majorly happens in your equatorial regions, or it can happen in other regions also. Like suppose any particular region where you have a lot of heating, lot of insolation. Because of that, you are having the cloud formation and you have the rainfall. So that is your convectional rainfall. Basically, convectional rainfall is due to the heating of the surface. Okay. Now, second is your orographic rainfall. Orographic rainfall में what happens that your warm, moist air is forced to rise. ठीक है, forced to rise. Okay. I have specifically told you, Emboy, that wherever you have the heating. Now, obviously, in the month when you have the ITCZ moving over the Indian subcontinent, so you have a lot of heating. Okay, so you find. Okay, so that in bits and pieces. You find that also. Okay. Now, what is orographic rainfall? How it is forced? Okay, Chandranshu, I'll explain this also. So now, warm moist air is like flowing. Okay, it is flowing this way. यहाँ आ गया पहाड़. So what will happen? So the warm air mass will like force to rise. The air will force to rise. There is a barrier in front of it. So it is not one mountain. It is like a complete. Suppose you have this Western Ghats. You have the Western Ghats. So when this southwest monsoon comes, okay, I'll come to that. So because of that, what happens? You have this. You have Western Ghats. So this southwest monsoon is forced to rise. This southwest monsoon winds is forced to rise. Now what will happen? Again, the same thing happens when it is rising upwards. The temperature is decreasing. Okay. When the temperature is decreasing, it is getting saturated. You find the rainfall over here. But there is interesting thing that in this particular slope, you find the rainfall over here. Okay, you find the rainfall over here. So that is your that is what we call the windward slope. Now, what is this windward? Towards the wind. Matlab towards the wind. So this is your towards the wind. This is what we call the leeward slope. And now what happens? Whatever the moisture it has, it shed on this slope. Now when it will come downwards, now it the temperature start again increasing. Temperature बढ़ना शुरू होगा. ठीक है, so temperature will start increasing. Now what will happen? That you will not find rainfall over this particular slope. This is what we call the rain shadow area. Yes. Okay, this is what we call the rain shadow area. Leeward slope cause rainfall in Tamil Nadu. Okay, I'll come to that. Okay, Mandi. Though again, the thing is, Indian monsoon and climate we'll be discussing tomorrow. Okay, since you are asking, I'll briefly explain. So you find the this rainfall, like because of your southwest monsoon, you find the orographic rainfall. Now, when it crosses the western ghats, you will not find much of a rainfall in Tamil Nadu. So that simply crosses this also. This wala southwest monsoon also crosses. Now, in the Tamil Nadu, you find the maximum of the rainfalls due to the retreating monsoon, northeast monsoon. What is this retreating monsoon? That we will discuss tomorrow. Windward slope, maximum rainfall, leeward slope, less rainfall. Yes, best example is this year, Mumbai and Pune. Mumbai and Pune. Have you ever heard that you have the floods in Pune? But like you find on a very regular basis, on like after a year or so, you will hear that you have a floods in Mumbai. Okay, floods in Mumbai. Because what happens that this year, Mumbai, though Mumbai and Pune are not very far away from each other. So you find because of your southwest monsoon, this Mumbai lies in your windward slope and Pune lies in your leeward slope. So that is the reason behind this. Okay, orographic rainfall. Next is your frontal rainfall. Now what happens in this? हाँ जी, यहाँ तक समझ आया कि नहीं? पहले ये बताइए. Orographic and convectional rainfall. Is there any doubt in this? Now after that we will move forward. Geography समझ आ रहा है या नहीं आ रहा है? Are you getting the sense of the geography? A very practical things are there which you can actually observe also. ठीक है? आ रहा है. Okay. Convectional rainfall, is simply because of the heating of the surface. Because of the heating of the surface, what we have discussed. Suppose in the equatorial region, so your air was rising. So that will, when the air is rising because of the heating, that will eventually cool down. ठीक है? Okay. ठीक है जी. मध्यम आ रहा है. चलो बहुत बढ़िया. ठीक है. ठीक. So next is your frontal rainfall. Now what happens in this frontal rainfall? That the this westerlies and the polar easterlies. Now this westerlies are very warm air mass since it is coming from the subtropical high pressure belt. Just imagine the air which is moving from the desert areas. What kind of a air mass that will be? That is coming from the Sahara desert, suppose. So that will be very hot. And the air mass coming from the polar region, that is your North Pole or the South Pole, what will that will be? That will be very cold. That will be cold air mass. Okay. So what will happen? This cold air mass and warm air mass will be like in front of each other. So that is why we call it as a front. What is front? We say that our forces are at the front. Okay. BSF is at the front. ITBP is at the front, or the forces at the front. आमने सामने है ना, in front of each other. So what happens here? Cold current and the warm current is like in front of each other at the subpolar low pressure belt area, approximately that area. Okay. नहीं, mixing of cold and hot current. बिल्कुल मंदी इसको आम भाषा में बोलते हैं लस्सी करना. बेटा ऐसा मत करो. ठीक है. We will come to the cold current, hot current, warm current. This is not the lecture. We have not yet discussed current is altogether different part. I'm talking about the air masses. ठीक है. Don't mix the concepts. Okay, so you have the warm air mass and the cold air mass. So what will happen? Now the cold air mass is very dense, isn't it? The cold air mass is very dense. The space between the molecule is very less, so it will be very dense in nature. The air will subside, so it will rise. So the warm air mass will rise and cold air mass will be near the surface. So cold air mass will push the warm air mass to rise. When the cold air mass is aggressive and pushing the warm air mass, sudden rise, that is what we call the cold front. So in both the cases, in this warm front and the cold front, both cases, your warm air mass is rising. In this case, warm air mass is suddenly rising, so you find very huge rainfall in a very short span of time. But in this case, warm air mass is rising. Okay, warm air mass is aggressive, so it will rise very slowly. It is like an elephant. Okay, very slow. So it will slowly rise. This warm air mass will slowly rise. So you will find cloud formation over a very long area, and you will find very slow rainfall over a very long period of time and a very long area. So that is your cold warm front. Okay, so that is your cold front and the warm front. Now eventually what will happen? So the whole of warm air mass will rise, and you have the cold air mass at the bottom. So you have the cold air mass at the bottom, and warm air mass rising. So that is what we call the occluded front. Okay, let's discuss again frontal rainfall, also known as temperate cyclone. First of all, where do you find this? Around 60 to 65 degree north and south, where you have the warm air mass coming from the subtropical high pressure belt and the cold air mass coming from the polar high pressure belt. ठीक है? हाँ जी, yes. यहाँ तक समझ आया? So this is known as temperate cyclones. Your warm air mass and cold air masses in front of each other. First of all, what is you have the stationary front. When the air masses are not moving against each other, the zone is called a stationary front. So first of all, what will happen? दोनों आमने सामने आ गए. ठीक है? So cold air mass and warm air mass now ready to fight with each other. So both are at the border, both are at the front of each other. Now there can be two cases. In one case, cold air mass is very powerful, लड़ने के लिए तैयार है with lot of ammunition. So what will happen in both the cases? Warm air mass is going to rise because warm air mass is light, less dense. That is going to rise. So when cold air mass is aggressive, so what will happen? The warm air mass it will lead to the sudden rise of warm air mass. So you will have the sudden rise of warm air mass. The transition zone where cold and dry stable air mass displaces a warm, moist, unstable subtropical air mass. The zone is called cold front. Okay. So what you will find the cloud formation because warm air mass is rising. Again, the same concept. When the warm air mass is rising, that will cool down. That will lead to the formation of cloud, and you will have the rainfall. Okay. The second concept is your warm front. The transition zone in the atmosphere where warm, moist, subtropical moist air displaces retreating cold air. So what will happen when the air mass is aggressive? That will slowly rise. Okay. So what will happen? You will have the cloud formation over a long period, long area. In both the cases, the final result is same. The warm air mass is rising, that is cooling down, that is leading to formation of cloud, you are having the rainfall. In both the cases, cold and warm front, same thing is happening. But the thing is, in this, warm air mass is suddenly rising, in this, warm air mass is very gradually rising. Okay? Yes, and other guys who have got this point. Finally, what will happen? This warm air mass will be completely above the surface. Effects will be different. Okay, effects will be different. In this way, yes, Vaishnavi, in this you will find the rainfall, huge rainfall in a short span of time, short area. Here you will find a very small rainfall, a very gradual rainfall over a long period of time. धीमी बारिश, ठीक है, so you will find over a long period of time, ठीक है. Now what will happen eventually? So your warm air mass has completely risen above, and you have the cold air mass beneath it. So what will happen now? So that is what we call the occluded front. That means the front has dissipated. That means war has ended. ठीक है, cold air mass को rise करना था, वो rise कर गई. So that is now the front is ended. So that is occluded front. This front form when the warm air mass is fully lifted above the land surface by moving the cold air mass becoming from behind. So weather becomes very calm, clear, stable. Okay. Warm air mass has risen, and you have the cold air mass. That is your occluded front. Why is cold air dry and warm air moist? Because why it is saying dry or cold? It is not always so. But generally, what happens that we are considering this as that since it is coming from the hot area. Now, as your temperature is high, the moisture carrying capacity of the air is more. When it is cold, since the space between the molecule is less, the moisture carrying capacity of the air is less. Try to understand this from one example. Okay. Take 2 glasses of water. One is hot water glass. One is your cold water, icy water. Now you have to add 1 spoon of sugar in both the glasses. Okay. In which glass your spoon of sugar will be added easily? Hot water or cold water? Hot water. Why hot water? Okay, local winds we will discuss. Okay. Yes, thank you for reminding me. We'll discuss. Because the space between the molecule is more in the hot water. In the cold water, the space between the molecules is very less. Okay. So that is the reason. Molecule expansion, yes. So that is the reason. Exactly. That is Chandranshu. So we're calling it as a warm, moist air. Okay. Space between the yes. Space between the molecule is more. Chandranshu. Next is my tropical cyclone. First of all, what is cyclone? Okay. What is cyclone? Cyclone is low pressure area surrounded by high pressure area. What is cyclone? Low pressure area surrounded by high pressure area. Runner of air. What is this runner of air? What is a runner of air? I'm not getting this runner of air. अच्छा, funnel of air. इसे हिंदी में कहते हैं अर्थ का अनर्थ. ठीक है, चलो कोई बात नहीं बेटा. ठीक है. So what? Where your wind moves from high pressure to low pressure area, isn't it? Yes or no? High pressure to low pressure area. Okay. ठीक है जी. Have I made the right diagram? What I'm saying, I have described 2 things. One is cyclone, low pressure surrounded by the high pressure area, and your wind moves from high pressure to low pressure area. So what will happen? So you have the low pressure at the center. So you have the high pressure everywhere. Arjun, hello beta, welcome to the session. So what will happen? So you're in the northern hemisphere. Your wind tends to move towards the right direction. So what happens here? This will be your anti-clockwise, or what we say, counter-clockwise. So you will find the direction of the cyclone in the northern hemisphere as anti-clockwise. ये किस-किस को समझ आया? In the northern hemisphere, you find the direction of the cyclone as anti-clockwise. समझ आया? Okay. जिनको नहीं समझ आया उनके लिए एक और एग्जांपल. For them, one more example. Suppose you have the low pressure, so you have the high pressure. that is your cyclone, है ना? That is your cyclone. So this. Okay. And now in the southern hemisphere, what happens in the southern hemisphere? The wind tends to move towards the the winds tend to deflect towards the left in the southern hemisphere. Left. So left, or left. So what will happen? That cyclone is clockwise in southern hemisphere. ठीक है जी? We have discussed this thing. ठीक है जी? Clockwise direction, cyclone in clockwise direction in southern hemisphere. समझ आ गया? हाँ जी. Another example. ठीक है? चलो अब बात करते हैं. Now let's talk about the tropical cyclones. It originate over the oceans in the tropical areas. It originate over the low pressure के 4 डायरेक्शन में, जैसे हाई प्रेशर उस तरह हाई प्रेशर को 4 डायरेक्शन से लो प्रेशर भी सराउंड कर सकता है ना. Yes. You have the high pressure surrounded by low pressure. ठीक है? So that is what we call the anticyclone. So the air will move away, high pressure to low pressure. So the air, like your air is subsiding and it is moving. It is like this way. It is subsiding and it is moving in all the direction. Okay, so it is coming from above and it is moving in all the directions. That is what we call the anticyclone. I'm going. चलो पहले अब डिस्कस कर लेते हैं tropical cyclones. So originate over the oceans in the tropical areas. Yes. ठीक है. Move over to the coastal areas, bringing about large-scale destruction and caused by the violent winds. Now, what is tropical cyclones? Now, what happens in this tropical areas? We find out that you have the low pressure center, at the low pressure at the center surrounded by the high pressure, and that is leading to the rise of warm moist air, that is leading to the formation of clouds. So this is what we call the tropical cyclones. You can see in this diagram also. Okay, this is now as per the scientist. Okay, Pratiksha, what I think Pratiksha is asking about the anti-cyclone direction. ठीक है, southern hemisphere में anti-clockwise, northern hemisphere में clockwise. ठीक है विकी, इसमें I think Pratiksha is asking about anti-cyclone. Anti-cyclone में उल्टा हो जाएगा ना विकी. ठीक है. Okay, so conditions favorable for the formation and intensification of tropical storms. Now what it says that there are few conditions which are favorable for the tropical cyclones. In the like what are the conditions? First of all, you should have the large sea surface temperature higher than the 27 degrees Celsius. Like around 25 to 27 degrees Celsius, you require temperature minimum in the oceans, in the tropical oceans. So always you find tropical cyclones starting from the oceans, especially in your news. You must have seen कि यहाँ से tropical cyclone बन रहा है, धीरे-धीरे it is moving towards the Odisha coast or the West Bengal coast. So that is, you must have seen that this thing happening in the Bay of Bengal. Recent also, you have two cyclones happened in this year. हाँ जी, which was those? Taute and Amphan. ठीक है? Taute and Amphan. It is not Taute from Myanmar. It is completely wrong, Mandi. The name is given by the Myanmar. Yas is the name given by the Oman. So it is not coming from the Myanmar. ठीक है Mandi? Okay. So that is your Taute that is happening in the Bay of Bengal and it is moving towards the coast of Odisha and West Bengal. ठीक है? So first of all, you should have the high temperature. So you have the presence of Coriolis force. Coriolis force means that because of this Coriolis force, what happens? That you have that tilt. Now Coriolis force is zero at the equator and it is highest at the poles. Now that is why you don't find the cyclones near the equator. That is the reason that you don't find the cyclones near the equator. As you move away from the equator around 20 to 25 degrees Celsius, so you find that tilt. That is very much required for the cyclone. Okay. हाँ बिल्कुल correct. So small variations in the vertical wind speed. So there should be a small variation in the vertical wind speed, so that is rising. So there is a continuous rising of pre-existing weak low pressure area. So you have a low pressure area over here. So upper divergence above the sea level system. So you have the upper air divergence. And finally, that energy which is intensifying is your latent heat of condensation. So the energy that intensifies the storms comes from the condensation process in the towering cumulonimbus clouds surrounding the center of the storm. So that is your latent heat of condensation. So you have like this high area, this is very low pressure area surrounded by, this is what we call the vortex. Now what happens when this cyclone move towards the coast? So this part will hit first. Now what will happen? You will have huge rainfall. Now as soon as it hits the coast, the main energy source is dissipated. Now you don't find any sort of like no air is rising. It starts dissipating. The tropical cyclone start dissipating. Dissipating means it start ending. It will lose its energy over here. Now what will happen? You will have a huge rainfall. Now suddenly there will be no rainfall. When you will have the eye, many people think कि अब खत्म हो गया cyclone, बारिश खत्म हो गई. No. So that is now authorities say, government say, no, please don't go outside. This is just a temporary phase. This is eye, which is your area is having the eye. you are yet to witness this particular vortex. ठीक है, पिक्चर अभी बाकी है मेरे दोस्त, ये वाला साइक्लोन आना बाकी है, मतलब ये वाला पार्ट अभी आना बाकी है. So you have the rainfall because of this vortex, and this vortex is yet to hit the coast. ठीक है, चलिए. So next is your tropical cyclone and the temperate cyclones. So temperate tropical cyclone move from east to west. Now why east to west? Why east to west? So you have the trade winds, northeast trade wind and southeast trade winds, and it is moving from west to east. That means just okay. So temperate cyclones spans over a smaller area, it spans over a larger area. Now you might say, sir, tropical cyclone is a smaller area. Now tropical cyclone hit on the West Bengal coast, and you are having the rainfall in Bihar, Jharkhand, eastern UP also. This is a huge area, big area. But temperate cyclone is having a much larger area. So it is in comparison. This is comparatively. It is in comparison. Velocity of winds is very high and damaging. It is comparatively low. So you hardly heard about any sort of damage due to temperate cyclone. Have you ever heard कि temperate cyclone आया और वहाँ पर बहुत तबाही हो गई? No. All these concepts, Mandeep, all these concepts you have to take in your mind. That is why I am going in that much detail. ठीक है, I could have simply told you कि अच्छा से ये चीजें हैं, ये रटा मार लेना हो गया. ठीक है. Examples of temperate cyclones you find in 60 to 65 degree north and south. ठीक है. These are so regular that the names are not being given. ठीक है. Now the main focus is on tropical cyclone because of the last year destruction happens. Suppose Yas, your Amphan last year, or Taute, okay, develops only on seas with a temperature more than 25 to 27 degrees Celsius. It can be developed on both land and sea. It does not generally last for more than 7 days. It lasts for 15 to 20 days. ठीक है, हाँ बिल्कुल. यूरोपियन कंट्रीज में, नॉर्थ अमेरिका में यहाँ पर आपको मिलता है. ठीक है. Next forms of precipitation I told you: ice and snowfall, rainfall. Sleet is like, you don't have to remember this, diameter of 5 mm or less. Drizzle, you say that it is drizzling, it is बूंदाबांदी हो रही है, so that is less than 0.5 mm. Hail is consist of large pellets or spears of ice, that is hailstorms. Next is your common types of clouds in the troposphere. Okay, so now is your types of clouds. First of all is your cumulus clouds. Now what is this cumulus clouds? These are your vertical clouds. This is like your cotton heap-like structure. You have the cotton heap-like structure, so that is your cumulus clouds. Okay. So below 6,000 feet, generally you find. Now the next type is your stratus clouds. Stratus means straight. So where you have the flat base-like structure. So that is your stratus clouds. Pooja, this is your recorded session. So I request you, if you find anything is being left, you can leave that space. Okay, you can cover it after the class also. Okay, you have the stratus clouds, you have the straight base. Okay. Okay. Next is your cirrus clouds. Okay. Next is your cirrus clouds. So cirrus clouds is your feathery structure, feathery clouds, or you can say high clouds. Okay, you can say high clouds. So see this, above 18,000 feet. Okay, above 18,000 feet. So that is your cirrus clouds. Okay, so cumulus, stratus. Another type is your nimbus clouds. Nimbus cloud is your rainy clouds. Kale ghane badal. So that is your rainy clouds, nimbus clouds. And the last you can type is say alto. What is alto? Alto is not your gadi of Maruti car. It is the simple meaning of alto is middle. So that is why you have the alto car, basically targeted at middle class population. Okay, so that is why they release that alto car. Okay, so that is the meaning of alto basically. Okay, now try to combine the various combinations. Yes, Mandi. Cumulus, stratus. So stratus, cumulus. So you have the stratocumulus. सभी वर्ड का सिग्निफिकेंस है, मतलब बिल्कुल बेटा सबका सिग्निफिकेंस है. सो व्हेन यू हैव स्ट्रेटस एंड क्यूमुलस, सो दैट बिकम्स योर, व्हेन यू हैव द स्ट्रेट फेस, स्ट्रेट बेस, एंड यू हैव द कॉटन हीप लाइक स्ट्रक्चर, सो दैट इज योर स्ट्रेटोक्यूमुलस. Alto stratus, when you have the stratus cloud in the middle height, around 6,000 to 2,000 feet, 20,000 feet, so that is alto stratus. Alto cumulus, so alto means middle, cumulus means again your heap like structure. Next is your cirrus clouds. Cirrus clouds is like your feathery clouds, high clouds. Then cirrocumulus, when you have this cotton heap like structure at a great height, so that is your cirrocumulus. Okay, cumulonimbus. Nimbus is your rain clouds. So when you have the clouds, this cotton heap like structure going from low to great height, so that is cumulonimbus clouds. So these are the clouds which are bring maximum rainfall, so that is your cumulonimbus clouds. So that what happens in your convectional rainfall, or say tropical cyclones, so that is the clouds which you find in the maximum rainfall. काले घने बादल कहते हैं, बहुत बारिश हुई, so that is your cumulonimbus clouds. Okay, so we have discussed stratus, stratocumulus, cumulus, altocumulus, altostratus. Another is nimbostratus. Okay, cirrostratus, cirrus, cirrocumulus, cumulonimbus. Nimbostratus. Now what is this difference between this cumulonimbus and nimbostratus? Both are nimbo. Nimbo is rear rain clouds. rain clouds. What is this nimbo? Basically, nimbo means now in this nimbo strata, since you have a very flat base, you find a very continuous rainfall. You find a very continuous rainfall for a long period of time. ठीक है? यहाँ पे you find a very huge rainfall in a short span of time. ठीक है? So that is cumulonimbus. The difference between cumulonimbus and nimbostratus. Nimbostratus में you find rainfall over a long period of time, long duration. Continuous rainfall, here you find very huge rainfall in a short area. Okay. One last topic before the question starts is your temperature inversion. हाँ, बिल्कुल. Cumulonimbus is like cloudburst. In cloudburst, generally you find cumulonimbus clouds. Yes, बिल्कुल. Okay, normal state of atmosphere. So you have warm air, so you have cool air. So as your air is rising, you have the cold air. So when the warm air rises, mixing with the cool air, causing the atmosphere to become unstable. But there is a term called temperature inversion. Temperature inversion. So cool air near the surface does not rise or mix with the warm air. Now cool air is dense. So that is like what we have discussed in the case of temperate cyclone. Occluded front. Do you remember occluded front? That warm air mass is above and cold air mass is beneath. So that is your temperature inversion. So calm winds and the inversion result in poor quality. Now in the month of October and November, what will happen? The whole of Delhi and the north of India will start choking. ठीक है कि सांस नहीं आ रहा है. Air quality index will rise up to 500 plus. Very मतलब it is as good as a smoking chamber. Why? What happens basically? So your cold air mass is, since your temperature start increasing, so you have the very cold temperature near the surface. Cold temperature near the surface, you have the smoke particles. So that smoke particles plus fog, so that leading to your smog, and you have a very cold air mass, so that is suspended near the surface, that is not able to rise. Above that, you have a high temperature. Okay? So the winter sun low in the sky supplies less warmth in the air surface. Warmer air aloft acts as a lid, so it is not leading the cold air mass to rise. So because of this temperature inversion, you find that the choking of the air. So that is in October, November, December, so you find this kind of a thing. Not today. अभी भी आपका बहुत ज़्यादा pollution है. People are going out, burning fossil fuels, but why you don't find the choking, the air quality index very poor in these days? Because you have the warm air is rising. ठीक है? So that happens because of the temperature inversion. ठीक है जी? चलिए. Now comes your question. Which one of the following types of the clouds is characterized by continuous precipitation? We have just discussed. So I know, so 59% have given this answer, 31 gave. मतलब 90% people have got this idea that nimbo is rain-bearing clouds. Rain-bearing clouds. So it is good. But I'm talking about continuous precipitation. I told you nimbo status you find a very continuous like rain. For a longer duration, you find the precipitation. But in cumulonimbus, you find thunderstorms. You find huge rainfall in a short span of time. Okay, now try to answer this question. Very simple. Match the following question. This kind of a question you can find in your serious examination. Cirrus cloud status, nimbus, cumulus. Okay, so you can easily do this question by elimination. ठीक है सर. Okay, 50% have got the answer. Now, if I have to answer this question, according to me, what I will do? Nimbus, I'm 101% sure that is rain-bearing cloud. So I will go for one. As soon as I go for one, I will cross these two options. ठीक है जी. चलो, next is your cumulus. So that is your vertically growing. So 3 or stratus, that is horizontally spreading, or cirrus, that is feathery appearance. Answer is your 2, 4, 1, 3. Okay, cloud burst, badal fatna. What is cloud burst? So let me explain once what is cloud burst. Now, why you have a huge rainfall in a short span of time? So you have a rainfall, like you have a falling of raindrops. But what happens because of the updrift? The water droplets is not able to fall down. At this updrift, this is warm moist air that is leading to formation of more water droplets. Again, that is want to fall down, but that is again the temperature is so high, the air is rising. So you can say the accumulation of water droplet. Okay, accumulation of huge water droplets. And beyond a certain point, that will not able to hold on itself, and it literally falls down, and it literally feels like badal fat gaya. So your cloud burst happen. So you have a huge rainfall in a short span of time. Okay, so now answer this question. I'll give you an idea. So it is defined as a sudden localized and very heavy downpour with a cloud thunder and lightning. It mostly occurs in hilly areas. It results in very heavy intensity of rainfall. That is 250 to 300 mm of rainfall in a couple of hours. It occurs only during daytime. 15 seconds or more. many people have got this right. Now, as per the definition of Indian Meteorological Department, when you find 100 mm rainfall, more than 100 mm rainfall in 1 hour, so that is what we call the cloud burst that we have discussed in the current affairs session also, if some of you are attending my current affairs sessions. So, sudden localized rainfall, that is right. It mostly, now if here it is being written it only occurs in hilly areas, so that becomes wrong option. It mostly, this is right. Very heavy intensity rainfall, 250 to 300 mm in a couple of hours, this is right. It occurs only during daytime. No, it happens during night time also. Answer is A. Okay. So, the technique of inducing rain from the cloud is what we call the cloud computing, cloud control, cloud engineering, cloud seeding. Good. Have you heard this term, artificial rain? Or it is also said that sarkari barish hui, government rainfall was there. ठीक है, resetting you in many other countries, China में, ठीक है, सरकारी बारिश हुई, government rainfall, artificial rainfall, yes, silver iodide, yes, good, MOE, silver iodide and dry ice. Now, why this? What happens because of this? Now, this acts as a hygroscopic nuclei on which your water droplets started accumulating, so that will lead to your cloud formation and you will have the rainfall. So that is not like 100% successful, but yes, this has been successful. So that is what the technique of inducing rain is what we call that, cloud seeding. Okay. So rain shadow effect is associated with which kind of a rainfall? Cyclonic, orographic, convectional, frontal rainfall. Very simple question. Are you getting that what kind of a questions can be asked from this topic? Somebody was asking me about, sir, question क्या बनेंगे इसमें? हाँ जी, समझ आ रहा है? Question, many people are not responding. Don't think that your answer will be getting wrong. Please try to participate in the quiz. That is for you only. If you not participate, you will not be able to remember. Please try to understand. This is the way you can make your learning active learning. Otherwise, it will be a very passive learning. You will get to know, okay, now what we have studied, we are discussing the questions related to that. अगर questions नहीं attempt करने, I can simply skip. This is for you only. मेरी practice नहीं हो रही, आपकी हो रही है, ठीक है? So please participate. Don't think कि गलत हो रहा है, ठीक है? Think that I'm getting something, I'm learning something. The eye of the cyclone has abnormally high temperature, lowest pressure. Abnormally low temperature, pressure. Clear sky, low pressure. Dense cloud cover, low pressure. What is the eye of the cyclone? तूफान से पहले की खामोशी. Many people have got this question wrong. Answer is your clear sky and low pressure. So I try to give you a hint. ठीक है? Shilpi. So clear sky. So I told you that when vortex will hit, you will have a huge rainfall. But you have a very clear sky. What happens because we have a low pressure here? ठीक है? Air was rising, but in this small patch, you have a clear sky. You feel that tropical cyclone is gone, but no, another vortex is yet to come. ठीक है? So low pressure, clear sky. Okay, which of the following? No, temperature was high, 25 to 27 degrees Celsius. Okay, so we are specifically talking about that eye. What is the specific characteristic of that eye? Okay, which of the following may be the true characteristics of the cyclones? Temperate cyclones move from west to east with westerlies. Tropical cyclones follow trade winds. The front side of the cyclone is known as the eye of the cyclone. Cyclones possess a center of high pressure surrounded by the closed isobars. Hurricanes are well-known tropical cyclones which develop over the mid-latitudes. True. Okay, answer is A. Okay, so temperate cyclone. Now, why the second statement is wrong? Why the second statement? Because the front side is your vortex. I is the center. Okay, cyclones possess a center of low pressure. Hurricanes are tropical cyclones, not over mid latitudes. These are in the tropical areas. So not over middle latitudes. That is 45-50 degree north. That is temperate cyclones. Middle latitudes where you find temperate cyclones, not tropical cyclones. Tropical cyclones you find in the tropical areas. Okay. So this is all about today's lecture. Thank you very much. Let's have a look at the leaderboard. So Adnan, 4 बजे class है बेटा, मेरी भी class है. So Adnan, MOE, Pankaj Sharma, Shilpi, Rishikesh, excellent. 5 guys are at 60. Then you have Sans Nings, Sumit, Mohammad Siddiqui, Parita, Aviral, 50. Vaibhav, Pratiksha, Korak, Aditi, okay, Aditi tak 40, Lalita, Rahul, Ishan, Chandranshu, Anuj, Devesh, Bhavani 30. Now, what I'm